Hi, I'm Dion from cert.mathsvideos.com. Now the first part of this question is straightforward, it's just a basic log question. We should be all be able to do this. We know that log A, well, considering if we're working in the same base, log A minus B is equal to log A over B. So that implies log to the base 4 of A minus B is equal to A over B. So that's 2x plus 6 divided by x minus 1 is equal to 1. Now we know what log means. Log to the 4 of this term is equal to 1. That implies that 4 to the power of 1 is equal to this term. So that implies 4 is equal to 2x plus 6 all over x minus 1. Now we want to eliminate the x minus 1, or the denominator, so we multiply both sides of x minus 1. So that implies 4x minus 4 is equal to 2x plus 6. And that implies 2x is equal to 10, implying that x is equal to 5. Only one solution there, x equal to 5. And our next problem is, here we're asked to find a general term here. So just to find a general term, what I'm going to do is write down the first maybe 2 or 3 terms, and then we'll establish a general term from there. So our first term, that expression there is equal to 10c0 times 3x squared all to the power of 10 times 1 over 2x all to the power of 0. That's plus 10c1 times 3x squared all to the power of 9 times 1 over 2x all to the power of 1. Now you kind of have to look at this for a minute just to try and establish a general term. So we know here we've got 10 here, we've got 10 here, so we're going to have 10, see something here. Then we're going to have 10 term here, 0 term here. Remember, them two terms are always going to have to add up. They're going to have to add up 10. So 10 and 0 is 1, or 10 and 0 is 10, and 9 and 1 is 10. So we leave this term here is equal to k. So that implies our first term will be, well, our 0 term in this case will be 10c0 times 3x squared all to the power of, remember we have to write most of these in k's here, so that's going to be 10, so it's going to be 10 minus k, because 10 minus k, our 0th term is effectively 10c0 3x squared to the power of 10 times 1 all over 2x power of k. So we'll just check this, right? Our first term is when k is equal to 0, the second term is when k is equal to 1. So that should be 10c1 times 3x squared to the power of 9, 1 over 2x to the power of 1. That's exactly what we have here. And certainly if we continue that on and fill out k is equal to 2, it should match the next term up there. So that's correct for the general term. Now our next question is we're asked to find the coefficient of x to the power of 8. Now, we're not really interested here. We're not really interested in the coefficients of x. We just have to find out what term the k is. So basically we write down 3x squared all to the power of 10 minus k times that by, write that down, yeah. 3x squared to the power of 10 minus k times 1 all over 2x to the power of k is equal to x to the power of 8. Now I'm not really too worried about our 3 here and 2 here because it doesn't really matter, because remember we're going to have a 10c term here as well. We're looking for the k terms, so no matter what our coefficients are going to be, our k terms are still going to have to match up. So that implies that we multiply, we actually write this. Just write this slightly different here. 10 minus k all over 2x to the power of k is equal to x to the power of 8. Now, it's just slightly better there when it's written like that. So now, just to get rid of the denominator here, we'll multiply both sides with 2x to the power of k. That implies 3x squared to the power of 10 minus k is equal to x to the power of 8 times 2x to the power of k. Now these coefficients must match up, so that implies x to the power of 20 minus 2k is equal to x to the power of 8k. That implies 20 minus 2k is equal to 8k, 8 plus k, so that should be 8 plus k. So 20 minus 2k is equal to 8 plus k. And that implies that 3k is equal to 21 is it? 12. Yeah, and that implies k is equal to 4. Sorry, I was mixing up the next question. That implies k is equal to 4. So that means we use our fifth term of k equal to 4. So we have our general term here, which is 10ck, so it's going to be 10c4 times 3x squared to 6. So 3x squared. Remember it's 10 minus 4 here, so it's 6 times 1 over 2x to the power of 4. So you know k is equal to 4, so I just have away. So basically we have to work this out. So 10c4 times that. I actually have it all, same we do in all the algebra, it's pretty straightforward. That works out at 1,5,3,0,9 times x to the power of 12 times 16 x to the power of 4. As you know here, the coefficient is always going to equal to 8. So that is equal to 9,568.25 x to the power of 8. And our next question here is to show there is no term independent of x. So let's go back to the formula here. Now when we're looking for the coefficient of x to the power of 8, we had x to the power of 8 on the right hand side when we were trying to get the coefficient of it. But now our coefficient is going to be x to the power of 0, because that's the only term independent of x, because obviously x to the power of 1 is x, x to the power of 2 is x squared. So then we're going to have our general term here was x squared all to the power of 10 minus k all over 2x to the power of k is equal to x to the power of 0. So then basically we have to find our k term here, and if k ends up being an integer, then we know that whatever integer that is, that's our term independent of 0. So like if k was equal to 0 there, that'd be our first term. So we're just going to multiply both sides by 2x to the power of k here. That implies x squared to the power of 10 minus k is equal to 2x. That's 1, remember, any number with power of 0 is 1. So it's 2x to the power of k. Now, that implies that x squared to the power, that means the coefficients here should equal. But remember we have a square term here, so we multiply this by this, so that's 20 minus 2k is equal to k. And that implies that 20 is equal to 3k, implying that k is equal to 20 over 3. Now, since 20 over 3 is not an integer, that means that there's no term independent of x in this. So if you found this video useful, please share it using social media. Cheers.